enterprise-wide product information management solution. We will be showing you how Sherpa can manage the product information for a complex electromechanical product throughout its life cycle. Looking closer at the device, we see three major product design components: mechanical case parts, a printed circuit board with a microprocessor, and software for the processor. The overall product configuration includes the specifications. We also have the source code for the microprocessor instructions and for the printed circuit board design, the schematic, the board outline, and the physical layout information. The mechanical case assembly design is composed of 2D drawings and 3D models for each part in the assembly. The manufacturing information is made up of the process plan and the associated work instructions for the assemblers on the shop floor. The project design team is comprised of the design participants, the project manager, design engineers for software, mechanical and electrical design, electrical and mechanical draftsmen, and the manufacturing participants, the manufacturing manager, a process planner, and a work instruction author. By including manufacturing in the design team, concurrent engineering techniques can be applied, as will be shown in the demonstration. The team will be using a number of different applications running on PCs, terminals, and workstations, all networked to servers. Supported platforms include Apollo, Digital, Sun, and Hewlett-Packard. Our demonstration will start in design engineering, where we will see the look and feel of the Sherpa Interface, basic check-in and check-out of product information, integration links between Sherpa and design applications, electronic approvals or signatures, and communication between team members. As you can see here, Sherpa is running in X Windows. The user interface features pull-down menus and pop-up forms. The interface will also run and look the same under X Windows, other proprietary Windows systems, or a non-windowed environment like a terminal. It is here in the Sherpa Vault that users retrieve the designs they wish to work with. When a checkout is initiated, Sherpa will determine whether the user has appropriate permissions to access the requested design, and if so, will copy it from the Sherpa-controlled storage into the user's workspace. With Sherpa, the controlled files can be centrally located or distributed throughout the network. The Sherpa system makes all access to the storage transparent to the user. He or she does not need to know where on the network the information is stored, since Sherpa will determine the location and retrieve it properly for the user. Sherpa will also prevent checkout of the design by other users, preventing more than one person from making changes to it at the same time. Moving to the checkout form, notice that there is a menu choice labeled Start Application. If our engineer places a yes here, Sherpa will automatically launch the application and load the checked out design into the appropriate CAD tool. Here we see the outline for the printed circuit board being loaded into a mechanical drafting application. At this point, the engineer has completed the board outline and will save his work, checking it back into Sherpa. When the check-in is initiated, Sherpa will verify that the user is the one who originally checked the design out. At this point, the mechanical engineer has completed the check-in and wants to place his signature on it so the design can be used by others. Sherpa allows you to create release procedures which define any number of milestones or steps a design must pass through from start to finish. For our project, all designs are managed by a 3-step release procedure: in design, sign off, and release. Although this particular procedure is very simple, they can be made as long and as complex as desired. You can also define conditions to be met at each step. The most common condition is an electronic signature. These signatures allow the appropriate people in the design team to electronically approve designs in a fast and efficient paperless fashion. Let's move back to our engineer and approve the finished board outline. Our mechanical engineer will do this from the sign-off menu. Notice that the system has remembered which design the mechanical engineer was working on, so this information does not have to be re-entered. He must now select the kind of electronic signature to issue. By querying the system, Sherpa displays the 2 approvals required to get the board outline to the release state. First, the mechanical engineer must approve the design to get it to the sign-off level. and then the project manager must approve it to get it released. Our designer is now filling in the reason for the approval. Sherpa now executes a process called an alert, which is an action that the system initiates due to changes within the product database. An alert can be something very simple, like sending electronic mail to the next person who must take action on the design, or something very complex, like taking a finished mechanical drawing, automatically running it through a translator into a format acceptable to another tool, and copying the results into the workspace of the user who needs it next. In our example, the mechanical engineer's electronic signature on the board outline moved it from level in design to sign off. This action triggered an electronic mail message to the project manager, who must review and approve the design to move it to level release. Let's focus for the next few minutes on the way in which a project manager would interact with the Sherpa system. Although our project manager is using a PC, this station could be a terminal or workstation. Here at the project manager station, we will show you the Sherpa user interface on a PC, communication with design team members, online design reviews, and electronic management approvals. The project manager will go into the vault and export the design into his own workspace for review. Export makes a copy of the data, but does not restrict access to it. Since the manager asks Sherpa to launch the application, the design is then downloaded to the PC and the application is launched. The manager is now reviewing the design, and when finished, exits the application in order to execute his electronic signature, which will move the design to the release level. When this approval takes place, the system will execute an alert, which sends mail to the mechanical engineer, notifying him that his design has been released. The management approval also generated another alert, which notified the electrical drafter via mail that the printed circuit board outline has been released. Sherpa has also automatically copied the finished design file into the drafter's workspace for use when she lays out the printed circuit board. Now we are going to pick up our design project at the printed circuit layout station. In this portion of the process, we will demonstrate the results of the alert triggered by the release of the printed circuit board outline and communication and linkages to manufacturing. The electrical design team members will be doing the initial layout work for the printed circuit board. This work will later be transferred to our printed circuit board production facility for completion and extraction of the required manufacturing outputs. Because of the previous alert, the electrical drafter did not have to try and find the correct approved version of the board outline, nor did she have to track it down somewhere out on the network. It was given to her at the soonest possible moment. This critical feature can cut weeks or months off development time on a complex project. The layout design is now finished, and the drafter will check the final design in and approve it, which will move it from in design to sign off. This signature will generate a mail message to the project manager requesting his approval. The manager will then approve the design in the same manner as before. This approval will generate a number of alerts. First of all, the electrical drafter will be alerted that her layout has indeed been approved. Second, the completed printed circuit design will be transferred electronically to the production facility. There, technicians would extract the appropriate manufacturing outputs from the design needed for the photo plotting, in-C drill, and pick-and-place machines on the manufacturing floor. Third, our project team decided upfront that this approval should be the trigger for the manufacturing process planner to begin work on the process plan to build our device. Thus, the process planner will get a mail message indicating the release of the PCB layout. In addition, the parts list file from the printed circuit design system will be copied into the process planner's workspace for integration into the process plan and automatically uploaded to the MRP system for advanced release planning. The fourth alert will copy the plot file of the printed circuit layout into the manufacturing work instruction author's workspace, which will later be integrated with the work instruction text. This concludes our demonstration. We hope you can now better appreciate the benefits that an integrated engineering and manufacturing environment can bring to your company. The Sherpa Corporation looks forward to working with you to define your needs and implement a cost-effective product information management solution.
Hi, I'm Steve Shotback. Today's demonstration was developed for you to visualize the power that an integrated engineering manufacturing environment can bring your company. Sherpa's customers are daily proving the dramatic returns they are achieving with their investment in engineering data management solutions. Customers such as Hughes Radar, Ford Aerospace, Eaton Corporation, Boeing Electronics, and Schlumberger Oil Well Services, to name a few. Each of these companies have very diverse businesses, but all share one common need. That need is the need to manage complexity in today's engineering and manufacturing environment. In fact, our customers define complexity in some of the following terms: the large number of designers and others involved in the design process, particularly with the emphasis today on design for manufacturability; coordinating their product information with their manufacturing sites, which are many times located in diverse geographical locations; the distributed nature of the engineering environment today, with a wide range of tools and frequently a diverse number of hardware platforms; managing the large number of engineering changes to constantly modify and keep their products competitive in today's marketplace. We welcome the opportunity to sit down with you, understand your needs, and propose a production solution. In fact, everything you've seen on this tape today can be made available in your operation in as little as 8 to 12 weeks through our innovative Quick Start program. Again, we welcome the opportunity to sit down and work with you. Thank you.